All right, in the second problem for Learning Target 11 notes, I'm going to go a little bit faster than I did in class, so you can pause it, rewind it. But in class, I recorded the first problem live in class, so it was a 20-minute video. This one should be a little shorter. The first thing we define the x and the y, so we read the problem, and ultimately, when they say how many of each vehicle, we realize that and you need to pause this and read it so that you can go as fast as I'm going. You need one variable to represent the number of cars and one to represent the number of buses. Doesn't matter which one, but we'll go with this order for now. Then we start reading for phrases that limit how many the attendant can park. And the first phrase is that the lot only has 600 square meters. So there's no more than 600 square meters. The second phrase that you'll notice is that he can take no more than 60 vehicles, and that word vehicle is very important. No more than 60 vehicles, because vehicles includes both cars and buses. There's no other phrases, even though in class some read the 6 square meters and the 30 square meters and thought that was a phrase that limited, but it's not a phrase that limits, it's a phrase of fact, and we'll see that in just a second. I'm going to use the concrete example 40 cars and 20 buses and see what would I do with the 40 and the 20 to see if those cars and those buses can fit in our 600 square meters. Well, if every car takes up 6 square meters, then 40 cars will take up 40 times 6 square meters. The buses, those 20 buses in our concrete example, will take up 30 square meters each. So 30 times 20 will tell us how much square footage the buses take up. If we add those together, it has to be smaller than 600. Well, this is not going to be smaller than 600, so this example doesn't work, but that again is not the point of a concrete example. The point is to have some numbers to play with the problem that you're given, because it's easier to play with numbers and it makes more sense to multiply 40 cars by 6 to get 240 square foot for the cars. But anyways, the 40 represents the number of cars, so 40 represents x. The 20 represents y, so our inequality is 6x plus 30y for any number of cars and buses that has to be less than or equal to 600. The next one's a little easier. No more than 60 vehicles. You might actually be able to just write this one without the concrete example. I mean, if the word vehicles implies you're going to take the number of cars and add it to the number of buses. So that'd be an x plus a y, and it has to be smaller than 60. But using our concrete example, again, 40 and 20, the 40 plus the 20 has to be smaller than 60, which again, 40 is x, 20 is y. We get our inequality that way as well. X plus y is less than or equal to 60. Last but not least, the logical constraints. You cannot have a negative number of cars, so x has to be greater than or equal to 0, and you cannot have a negative number of buses, so y has to be greater than or equal to 0, and those are the logicals. We'll put them in slope-intercept form before we decide what we're going to label our x and y axis as, because right now you may be thinking you need a 600 on your y-axis, but once you put it in slope-intercept form, you definitely don't need 600. We subtract our 6x, divide by 30, get negative 1/5 x plus 20. So our y-intercept's 20. We clearly don't need a 600 on the y-axis for this graph. We just need a 20. The second graph, when you put it in slope-intercept form, needs a y-intercept of 60. So if we need a y-intercept of 60 and 20, I'm probably going to count by something like 10. So I'll count by 10, label by 20s. So I'm counting by 10, but labeling every other. I'll count by 10 on the x-axis as well. It's always best to count by the same thing so that when you're graphing a slope like -1, you can still go down 1, right 1, because you're going down 10, right 10, which is equivalent to a slope of -1. And now we need to graph these 4 inequalities. The first one, the y-intercept 20. Start at 20, and the slope is -1/5, so down 1, right 5, down 1, right 5. Solid line. And then the second inequality starts at 60. The y-intercept is 60, and it's down 1, right 1. And this is fortunate. We just graphed the same point we graphed on the last line, so we clearly know where the two lines are crossing. The two lines are crossing at 50, 10, just in case we need it later. And then the last two lines, x is greater than or equal to 0. X equals 0 is a vertical line. I should be labeling these to be doing what I said I would do all along. Go back and label these two as the original just in case we need them. We won't, but it's a good practice. That's x equals 0. And the last line, y equals 0, is the horizontal line, the x-axis. So grab our line tool. Y equals 0 is that line. All right, now it's time to shade. X is bigger than 0, y is bigger than 0, puts us in the first quadrant. The other two lines, the diagonal lines, the ones that have a slope of -1 and -1/5, both say less than or equal to, less than or equal to. So if you're shading below both of those lines, you end up in this area, which clearly has 4 vertices, 1, 2, 3, 4, to plug into our function, which we're going to need to go back and write because I think I forgot to do that. Yep. But the 4 vertices are 0, 20, 0, 0, 50, 10, and 60, 0. The cost function, which I neglected to write earlier, let's see, go back and mark through everything that we've already used to graph, and there's only one thing left, $4 and $8. $4 for every car, $8 for every bus. If we used our concrete example of 40, our cost would be $40 times 4, and 20 buses times $8. Add that up, and this business would be would have to pay 4 times 40, 160 plus 160, $320. But that's not the point. The point is 40 represents x, 20 represents y, so our cost function is 4x plus 8y. So again, the concrete example is only to help you come up with this equation. If you don't need the concrete example, it actually confuses some students. You don't need to use it. Just write the function that represents the cost. If you're not needing the concrete example, don't use it. So now back to where we were in the table. Our cost function is 4x plus 8y, and we'll plug in these points. We can do this verbally without writing it out. When you plug in when you plug in the point 0, 20, it's 4 times 0, 0, plus 8 times 20 gives you 160. When you plug in 0, 0, you get 0 plus 0, you get 0. When you plug in the point 50, 10, it's 4 times 50, 200, plus 8 times 10, 80, which is 280. And then last, 4 times 60, 240, plus 8 times 0, which is 0. And now we have all the information to answer the question above. How many of each vehicle should the owner allow in his lot to minimize the cost of paying his attendant? Well, the minimum cost is $0 with 0 cars and 0 buses. Okay, immediately followed by the next question, so that was the minimum cost as well. In this situation, is minimizing his cost necessarily the best thing to do for his business? And the answer to that is clearly no. If he doesn't park any cars or any buses, yes, it minimizes his cost, but he doesn't make any money at all. So minimizing his cost wouldn't be the best thing. So let's do a little hypothetical here. Let's pretend that the 4x plus 8y wasn't what he had to pay the attendant, but what he made for every car. He made $4 for every car, and he made profit $8 for every bus. Then the problem would change to thinking about the maximum profit if this were a profit function. And then we would go with this option. $280 is his maximum profit with 50 cars and 10 buses. Again, that's just a hypothetical since the 0 cars and 0 buses was the minimum. But anyways, that is learning target 11. The hardest part is taking the paragraph and turning it into the 4 inequalities that you need to graph to find the maximum or minimum. and it just takes practice. And we will be working on most of them in class. There's only 6 homework problems, and we will do probably all 6 of them in class together at some point.